Hi, good morning everybody and welcome to CDG's webinar program. Today's topic is rapid plastic flow analysis software focusing on the products CADMould and Varamos from Simcon. My name is Grant Cameron and I am Managing Director of CDG. Thank you for joining us today. CDG are official Simcon partners for the UK and Ireland. The agenda today is to introduce you to Simcon, to discuss the benefits of simulation, focusing on CADMould and Varamos software products, and going into a detailed technical presentation of those products. To begin with, I'd like to introduce you to Simcon. Simcon are a company based near Aachen in Germany, and they have been developing plastic injection molding software for over 30 years. They were founded in 1998 from the universities in Aachen. Over the past 30 years, over 400 man-years have gone into development of their software applications. They have over 6,000 customers worldwide, and thousands of projects have been undertaken using their analysis software. For CDG, we are their sole UK supplier of software, training and services using this software. So let's ask the question about simulation and look at the challenges for injection molding design and injection molding of plastic components. So the cost of that process is very high in terms of tool design, tool manufacture, and then the overall cost of production. So anything that can be done to reduce those costs can offer massive benefits. The speed of the process for tool design, tool manufacture, and for the injection molding process is critical. Anything that can be done to enhance the performance of these processes is beneficial in terms of time and money. And the accuracy of the project for molding plastic is obviously very critical to everybody concerned. Anything that can be done to improve the accuracy of the final molded part is important. It is possible to undertake the process of designing and developing plastic molded products using more manual methods. So these methods could be doing some calculations or even going through an iterative process of trial and error. These types of processes are much slower. In fact, because they're slower, they will cost more money and they probably won't deliver the level of accuracy that one could get by simulating. So this is what Simcon, through their software products CADMould and Varamos, are offering, is a cheaper alternative in terms of developing plastic products, faster times and more accurate plastic parts at the end of the day. So with CADMould, we can look to eliminate errors, reduce cycle times, reduce the temperatures of the process and therefore energy use, reduce clamping force, which will enhance tool life. The speed of the process can be enhanced in terms of the whole process and in fact the cycle times for injection molding. In terms of accuracy, we can simulate the results of the plastic molded part to anticipate and compensate for items such as shrinkage and warpage. We can also look through a whole materials database to choose the optimum material for that particular part. CADMould and Varamos are widely used throughout industry. Here is a selection of customers of Simcon. Just to use one of the quotations from Shulkin, we decided to work with CADMould by Simcon because its computation speed is significantly faster than competing products. With the Simcon software, it is possible to achieve a return on investment within 5 months, and this is typical. And in terms of savings, financial savings, looking at the whole cost of injection molding process can be up to and even beyond €100,000. CADMould offers end users a simple to use tool, very fast analysis times, and very accurate results. If I can highlight the title, CADMould's 3DF technology. 3DF is a 3D framework which is unique to Simcon and CADMould. CADMould is a shell mesh system where the upper and lower boundaries are linked together. The links are split into 25 nodes, and the nodes, each node is used for computation purposes to create a high resolution result. Looking at how the plastic flows through the upper and lower walls of the plastic mold part, we can look at the shear forces on the edges are increased, and the speed of the plastic flow in the center is also increased. Between the upper and lower walls, we divide the analysis into 25 node points. As the plastic flows through the mold, the plastic solidifies as it goes through. This reduces the cross-sectional area, but we still are able to analyze the 25 node points, and this enhances the resolution and accuracy of the results. This way of processing the data for plastic injection molding is unique to Simcon and CADMould. So the quality of the simulation plus the quality of the data gives us accurate results. Simcon utilizes a database of over 7,500 materials with all the parameters supplied by the manufacturers of the plastic. These parameters are fed into the software to deliver the results for that specific material. These results are verified through 30 years of testing using injection molding equipment. So Simcon have proven that their software is extremely accurate in terms of the actual results that are produced from the molding process. CADMould is a modular system. We recognize that different companies, different parts and different applications require different parts of the process. So this is a highlight of the key modules of CADMould, going through filling, warping, packing, unwarping, looking at the thermal box, the cooling phase, the effects of fibers within the plastic, looking at different materials such as rubber and foam. So one can customize the software for your particular application, and Simcon had developed key packages for key applications in key industries. So here is a selection of some of those packages. The Simcon CADMould software is very flexible in terms of making an investment. One can choose whether to have it locally on a computer or a floating license or on a server. This is important because computation analysis is very computer intensive, and one needs to manage the IT side of things very cleverly to get the maximum performance from the software. One can use a single license or multiple passes, and it is possible to buy or rent the software. I'm now going to hand over to my colleague, Tom Preston, who's going to go into more technical details about the products.
Hello there, I'm Tom Preston. I'm going to be taking you through a technical demonstration of the Simcon software regarding CADMould and the Baramos software. So thanks to Grant for that brief introduction into the CADMould software and the underlying engine for both pieces of software. I'm going to start with a brief overview of a setup of a part to be molded, and then looking at some of the results that we can achieve from the simulation. So I'm just going to start off with a simple importing of a part. We can import directly from an IGIS. You can see that as it's imported, we convert it to a mesh. The mesh is important because we always simulate using a mesh. We also need to prepare this mesh for optimum simulations. So as you can see, the imported object needs to be remeshed for a more uniform size. So you can see how quickly we've gone from a complex mesh to a very uniform mesh across the whole of the shape of the part. Very quick and easy tool to use. So from this, we can obviously rotate around and see the uniform sizes here, use some of the predefined views. The user interface is very simple and easy to use within CADMould. So what we're going to do next is just have a remove the node shape. So just having a tick box here so we can see the shaded model here. We're then going to go back to the main point and add an injection point. So this is a very simple process of adding where the material is going to flow into the part cavity here. So we're just going to see that we can add multiple injection points or just a singular one at the end here. We then go to the material database and we can select out of the many different materials that we have on offer. So you can see the massive amounts of materials that we can choose from. We can also quickly search for a particular type of material or particular grade of material. So simply selecting an ABS style material here. We then can move on to the process parameters for this simulation. And we can do a quick calculation to find some best values for this particular setup. We can then manipulate these to suit our preference of this simulation. So simply adding the packing and warping analysis to this part. We then move on to giving this part an ID for the simulation, so we can have multiple iterations within a single file for different setups, different times for the molding, different pressures, temperatures. You can see how the identifier here is just showing we're on the first iteration. We can see all the information about this simulation here and add descriptors to this to make it easier to reference back to them. So now just pressing the simulate button, we can now simulate. So moving on to some of the results now, we're just going to look at the flow into the part here. So the simple time steps throughout the part. You can see the process as it fills the cavity here. Very quick process of simulating this. You can see how the flow is progressing through the part. You can start to see where air gaps might be created, air traps, sorry. We're going to look at more complex simulations such as the warping and deformation of warping. So this is the cooling effect as such. So just looking at the shrinkage of the part here, we can see overall what the effect of this process is as such. So moving on to the Baramos software, we're looking at how this software can be fully utilized to get the maximum amount of profitability out of the software. So this is now where we can measure, optimize the process, and perform better than the rest. So a traditional simulation process starts with the defining of the injection molding parameters. We simulate to find the outcome. We then evaluate the results to gain some knowledge from this. So this is the iterative loop of adjusting the parameters, getting a simulation, finding results, and beginning again and again. And we end up a lot of the time with a good enough analogy here. Whereas with the Baramos software, we swap this around. So now we have the defined outcomes as our constraint here. We run the Baramos software and we get the optimal injection parameters for the part here. So we reverse the process had the desired outcome, calculate the optimal parameters. So just having a quick look at the steps through this process. So we're entering the targets and free parameters of the mold. We're finding the most efficient combination of simulations, experiments to find the variance in the parts, and then automatically running the virtual experiments as a simulation using the CADMould software. So a very fast software engine to be based off of. We then model the parameter behavior based on the simulation data, so we can see how they are affecting each other with the different variables. Many different variables can be selected from the CADMould software to be varied, such as injection points, such as flow times, such as temperatures, all to be controlled as such. So we then have a very easy interactive display to vary these variables with instant feedback, and we can actually optimize these variables to find the best outcome for us. And now we can then verify this with the CADMould software. So it's a full integrated solution. So just a quick look at the Varimos interface here. So we can see some of the process parameters that we're iterating on as such, with quality features that we want to figure out what are the different best outcomes here as such. So it's a really nice, simple interface with toggleable options here. It also has the ability to optimize these variables for the best outcome as well. So really nice, simple system of working here. So just moving on to some case studies, we're using the Varimos software. So we have a really nice part here where it's a pressure sensitive bottle for a water filtration system for a drinkable drink dispenser. It's got very tight tolerances. It's a functional, crucial part to this dispenser. So the problem with this part was that we were getting too oval of shape. The root cause was an unbalanced filling. So the ultimate idea for using the Varimos software is to get a more balanced filling. The other constraint was then to add a fiber reinforcement to the material as well, which is another aspect of the CADMould that can be used. So looking at how the simulation was set up, we had a number of virtual sensors on the part, which allowed us to measure the pressures at these areas of constraint. We then also identified 5 areas of wall thickness that we could vary to achieve a better flow constraint. So the before and after of the simulation here, you can see how that the wall thickness changes ever so slightly to allow the flow to be better throughout the part here. So that is all done within the Varimos CADMould software as such. So the optimization here is really key to show how it can be used to improve the part quality here. So the ending result using the Varimos software is a much better optimal shape produced using the injection molding. So just looking at some of the values here, we can see that there's 24 sensors attached to the part here, and we can see that after optimization, we're well within tolerance for the symmetry of the part. So moving on to another case study here, we have a cap of a little makeup dispenser here. The trigger button obviously showing here that the simulation showed where it was going to finish the mold under a certain constraint as such, and how the reality compares to this as well. So we can actually see how well CADMould is processing this part as such and showing how it relates to reality. And we are really within the same shape, same procedure here. So really nice to see how this compares to reality. Another example where Varimos was used to eliminate a burner by subtly changing the wall thickness. We can see that the simulation showed exactly where we were going to have a small indent in the part here, a dwell as such. So we wanted to optimize the wall thickness to allow for this not to occur as such. So the wall thickness at the back there was optimized so that the flow was consistent and also filled completely. Another look at some case study here is a micro injection part with some high constraints here, some complex mesh. So the mesh structure is only 0.1 millimeters in size. It was used like a filter system as such, so it's a very small filter system. You can see how the filling was going to be finished just at the end point here. So the last fill points are obviously shown up exactly how it is in reality. So again, a really nice viewpoint that what we're simulating is what is reality. So the accuracy of the simulation also is really good for biopolymers. So interesting how this relates to the material database with the interest of biopolymers out nowadays as such. So the simulation relating to actuality is within 0.1 millimeters of size as such, and the pressure loss is again within 1 bar of the true value. So really interesting how the simulation is so true to what is reality. So just looking at some more case studies here. So we're looking at a glove box here, and how at different time points as such, we can see how this relates to reality again. So varying the time of injection, can see the results and how that plays out as such. It's lovely to see how that kind of can be varied within the software and come out in true reality, and how that suits each other. Another good use of the CADMould software is for shrinkage and warpage for NFC materials, with examples in the automotive sector. So in this part, we can see the simulation has examined the warpage of the part after injection molding, and we can also see how that relates to reality. And again, very close approximation with really interesting results of the simulation compared to reality. Simulating behavior for shrinkage and warpage for polymer filled with biocomposites. So looking at what the simulation suggests compared to reality. And again, we are pretty much spot on with what was filled, and also the shrinkage and warpage of the part as a result. So for Project Aquacomp, so again, looking at the shrinkage and warpage of a biocomposite, we can compare the real world warpage here. So again, the measurement is really, really accurate for a complex material like a biocomposite. Sink mark detection, really effective within here. So we can see the simulation has outputted a sink mark of 0.23 millimeters with compared to the measured sink mark, which was 0.25 millimeters. So again, really accurate results. Seeing where those sink marks are going to be, we can remove those using the Varimos software or changing some of the variables in CADMould. So a really interesting and cool use case of the Varimos optimization is with reducing of sink marks and saving on material use as well. So we're reducing the amount of iterations that we need to go through the process. We're reducing the amount of waste material with this. So the before optimization, you can see all of the areas of high sink marks around this really large part, compared to the after the Varimos optimization, which has greatly reduced these sink mark areas. So there's the massive amount of reduction in use of material here, and also the problematic areas. Here's another example of a flat plate where a customer was facing quality issues. The quality issues was the measured points around the edge. The warpage after injection molding was massive, so up to 4.95 millimeters in certain points. Even with rib sections, it was still coming out with this massive amount of warping. So we can see some of the kind of close-ups here, the massive warping here. Now, after the simulation with the Varimos to compensate for the optimization warping, we can see that it's greatly reduced, well within tolerance of the part here. So just to call out some more use cases here, we have Alexander Wolf from Continental and Thorsten Ricking from Odell, just describing how Simcon has helped them with simulation and also productivity.